You end up with problems. You have to make sure that resources and costs are being balanced, that incentives are being correct, so that we get the right emergent behavior. And it's fascinating how this all works. And so I thought you might like to see a little bit under the hood. We have transaction fees. We're going to go into some of the depths of, what makes up the transaction fee, because you may find that interesting, just to see, what's going on under the hood. Although, as a developer, it's pretty simple, but you might want to understand it. So we're going to go through that. And we'll talk about some things like mirror nodes that we really haven't talked about a whole lot. So there are payments. The network is paying nodes to be nodes in our network. The network is made up of these nodes, these computers. That's an incentive for them to do so. And it is even paying proxy staking users. So users can be helping the network to work well by proxy staking. We'll talk about that. If you want to use the network, you pay a transaction fee, as you might imagine. And so that's coming in while the payments are going out. And then you can also have data micropayments, which is really interesting. You can be making these little tiny micropayments for information from the network, from the nodes, and even from mirror nodes, which is anyone who wants to be can be a mirror node for free. And then you can sell information to people, and you can sell services around the information to people. So we'll talk about that. So this is the network. A bunch of computers, each of those circles is a computer, and the purpose of these are to come to consensus. If you store a file, they all store the file. If you run a smart contract, they all run the smart contract. They come to consensus on what the results are. They come to consensus on what they're storing. You're feeding in transactions. They come to consensus on the exact time of each one and what order they're in, all that stuff. And you see there's lines between them all. They all talk to each other over the internet. They're fully interconnected in that sense. Now, when you want to do a transaction, you want to move some H-bars from one account to another, pay someone, or you want to run a smart contract or store a file, one of our 3 services, or one of the services in the future. If you want to do a transaction, you make your transaction, you digitally sign it, so no one can do this in your name, and you send it to one of the nodes, any of the nodes. Just pick a node on the network, you send it to that one node. What's that one node going to do? Well, of course, it's going to gossip it to the whole network. So it will spread out. So the whole network is going to see this transaction that you've done, and all of the nodes are going to be collaborating together to come to a consensus in an ABFT way. It's asynchronous, it's kind of hard to stop it, and you come up with the consensus for it. Now, that is what you do with a transaction. A query is slightly different. You just ask the node, oh, what's my account balance right now? And the node tells you. The node has all the information. Any random node in the network. I could submit my transaction to one node and then just ask some other random node, hey, did my transaction go through? And it can tell you. So a query doesn't bother everybody else. A query, you don't have to gossip anything. You don't have to talk to the other nodes. A query is just asking one node, give me some information. And so the one node gives you that information and you're done. It's just a conversation between you and the node. So queries and transactions are a little bit different in what resources they're using. Are we having to gossip it? Are we having to check digital signatures? Does everyone have to check a digital signature? Does everyone have to do consensus on it? Transactions take a little bit more of our resources than the queries do. Okay, so we should reflect that in the cryptoeconomics of it. So when I do a transaction, it's exactly what you would imagine. You pay a transaction fee, and you send it to some random node, and then they send it to everybody else, and you would imagine that maybe the node takes some of that, and then the network as a whole gets some of that. That's what you would imagine, and that's what happens. Why have transaction fees? Why not make it free? There ain't no such thing as a free lunch. That's the sad thing. Why not make it hidden fees? We could have a magic tax, where just whatever account you're holding magically loses money every day. I don't really like that. Or we could do inflation, which is an even more invisible hidden tax. I'm not really like that either. I think that it's cleanest if we make everything clear. Transaction fees are clear. You just pay for what you use. You're not paying for things you're not using. It's very clear that we are aligning the resource usage with the pricing and the costs. We're trying to make sure that we incentivize people correctly. No one's incentivized to just flood us with lots of things or store my file for 1,000,000 years. By the way, we don't say you pay once to store a file for eternity. That doesn't make any economic sense. You pay according to how long you want to store it. And if you decide later to store it longer, you can pay some more to store it longer. In every case, we're trying to make sure that the economics reflect the exact resource usages. Okay, so to the user, all you're doing is paying a transaction fee. Our SDK calculates it for you, it's simple. But wouldn't it be interesting to know what happens to that fee? And so what we're going to talk about is how that fee was calculated. Now, if you're a developer, you just call the SDK and it does it for you. It gives you a single number. In fact, it even creates the transaction for you with that single number in it. But what's interesting is to look at where that number came from. So, let's do that. Let's kind of break it apart and see what's actually happening to your transaction fee under the hood. Because this is interesting, and it also allows us to think about the economics, think about emergent behaviors and incentives and all those sorts of things. Let's make sure we get it right. That's what we're trying to do across the board here, is do it the right way that will be sustainable and self-supporting and will last. So, what do we do? Well, you might imagine that we would want to have a network fee, node fee, and service fee. These three things. Why would you imagine that? Well, the network fee is because this one node, by accepting your transaction and gossiping it, is kind of obligating all the other nodes to do a little bit of work. They all have to gossip your transaction. They have to use some of their bandwidth. And then they all have to check the signatures on it. So they're doing some computation. And they have to store it for a few seconds at least, or maybe a minute in RAM, just to remember that this is something you've done until they finally get the consensus. So for a few seconds or a few minutes or a minute, you're using up some of their RAM. Every computer in the network is obligated to spend some resources. No, it's really, really tiny amounts of resources. That's why this can be a fraction of a cent, and the entire transaction fee can be a fraction of a cent. But we're breaking it down. Where are the resources being spent? And so how is this fee being used? So part of it is just being used as a network fee. And this is simply the amount of effort and so on that it takes to spread your transaction to everyone, which depends on how many bytes are in it, and check the signatures on it, which depends on how many signatures there are to check on it, and to store it in memory for a few seconds or a minute, which depends on how many bytes are in it, and that's it. That's the network fee. Now, in addition to that, this node has done you a favor. They submitted a transaction for you. And the other nodes didn't do that favor. This one node did you that favor. You should incentivize the node to actually be willing to do you favors like that. So there needs to be a node fee that actually goes to the node. If we didn't have any node fees, then these nodes could say, hey, I'm just going to be a node in the network, but I'm not going to ever talk to any of the clients. And then the whole network doesn't work. Now, I think lots of nodes would be nice enough to do it anyway, but what we want to do is get the incentives right. So what we do is we say, every node is going to get this node fee. And again, it can be very small, because how much effort is the node doing? Just a little bit of bandwidth to have this conversation with you. The conversation is really simple. You send it one message, it sends back one message. That's the whole conversation. So it's not very much, but it's a little bit. We want to make sure that a little section of your transaction fee is going to the node to encourage it to actually process transactions for people. I mean, to accept them and forward them. So you have to have this network fee because the whole network's obligated to do something. Not very much, but a little bit. You have to have a node fee because the node needs to be incentivized to do something. Not very much, but a little bit. And you need to have a service fee, which also doesn't need to be very much. Well, it depends on the service. I guess if you want to store a terabyte file for a century, that would be a lot. But generally, the service isn't very much. And the service is, well, what is it that Hedera is actually doing for you? If you said, store my file, then the service is, it's storing your file. If you say, run my smart contract, then the service is, it ran your smart contract and stored a record for you to get the results. If you do a cryptocurrency transfer, the service is, they transferred it. Or maybe they transferred it and you also asked for an official record that you could get state proofs on and prove to a third party that it went through. All those are the services that every single node has to do so they can check up on each other. We don't trust anyone. We trust the group to be mostly correct, mostly honest, but we never trust any individual node. It's Byzantine fault tolerant. So the service fee is dependent on exactly what it is you're asking the network to do. If you're asking it to store a file, it depends on how big the file is and how long. If you're asking it to run a smart contract, it's how many steps you want your Solidity contract to run, the gas. You're saying how much gas you want to give it. If you are, and I don't know if you're aware of this, we use Solidity. In fact, we just had a hackathon, and I can't wait to see the stuff from the hackathon. I'm going to see that later today. But apparently some people did some amazing things at this hackathon. And some of them used smart contracts in Solidity, because we support Solidity. And we'll add other languages later, but right now it's Solidity. So the service fee is for all of that. A cryptocurrency transfer is really simple. You're basically just changing two numbers and doing a little bit of if-then, did I have enough H bars to send them? And maybe storing a record for you. I keep talking about records. Records is a thing that allows you to have this proof that something happened, or that your balance is a certain amount, or the result of the smart contract was a certain amount. Sometimes you don't even need a record. You're good enough with just a receipt that says, yeah, this note says that my thing went through. But if you want a record, you can do that. It's an additional service. So, this is how your transaction fee is broken up. Pretty straightforward, and, best of all, invisible. But remember, the whole point here is to stop attacks. We want this thing to be trustworthy. This is all about trust. In fact, if you really want to know about trust, come to my second talk in whenever it is. I don't know what I'm talking. Sometime today, and we'll talk about how we're really doing trust with COQ proofs, formal methods, having a computer check the math proofs because I don't even trust my own math. But for this, what happens if a node were to be malicious and were to just spam the network with lots of fake transactions from some user that doesn't really exist? A fake client. What if there is no client and this node says, oh, a client just gave me 10,000 different transactions. Would you all please gossip them around, waste your bandwidth moving those bytes around, and would you all please check the digital signatures on them? And then everybody gossips them, everybody checks the digital signatures and says, nope, they're false, and throws it away. At least we're not doing the service part of it, but you are wasting their bandwidth and their signature checking and the RAM for a few seconds or a minute. You are wasting resources of the other nodes. Now we have some throttling. There's a limit to how much one node can send to the network and how fast it can send it, but we want to not incentivize them or not allow them to easily waste resources. Anytime you're using resources, you need to have incentive structure in our cryptoeconomics so it doesn't happen. Or at least so it is disincentivized. That's the goal. So how can we do that? Well, you know what? The user, the client, paid part of their transaction fee was a network fee, which reimbursed everybody for gossiping it. That's fine. The node doesn't care about that. But if the node is malicious and there is no user, we could break that top line into two pieces. We could say, when there actually is a client, the client pays the node pays the network, and the two payments are equal, so from the node's point of view, it's a wash. The network fee is sort of invisible to the node. But if the node is malicious, and there is no client, it's a fake client, he just made up, or she, he, or Alice, or Bob, whoever the node is, just made up a fake client with fake transactions and fake signatures, then that second half of the line means that the node is actually paying for the network fee. And all the effort of gossiping and checking it and keeping it in RAM for a few seconds or a minute is all being paid for by the node itself. And so if the node is honest, then there is no fee at all. And if the node is dishonest, then it has to pay a whole tiny fraction of a cent for each of these fake transactions. And the rest of the network doesn't care. The economics work out. The amount of resources that this malicious node is using are perfectly paid for. There's no harm, and there's no service fee involved because everyone just throws it away. They say, hey, bad signature, I throw it away. So everything works out smoothly. So we're good with malicious clients, we're good with malicious nodes. The node actually does a pre-check. If the client is trying to save a terabyte for 1 trillion years, but doesn't have any H-bars in their account, then the node is just going to do a pre-check and it's not even going to happen. Or if a client couldn't even afford their network fee, then the node will do a pre-check and make sure it doesn't go through. So everything at every step is designed to make it smooth, frictionless, and secure so that you can trust that it's working correctly. So, that's the transaction fees. But again, that's all invisible. This is what the client sees. This is what the developer of software for the client sees. You pay a transaction fee when you do a transaction. That's it. You don't even think that there's a network out there. You just say, I'm paying this node and there's this transaction fee. Very clean. The SDK calculates it for you. But it's fun to look under the hood. And the details are always interesting, and the game theory of it is always interesting. The economics of it are always interesting. And, I don't know, math is fun. Math is always fun. You laugh as if that's not true. So, let's talk now about why someone would want to be a node. Remember, we're starting with the council members running nodes, but the plan is to have a whole planet running nodes. Anonymous people running nodes, millions of people running nodes. This is the plan, is that over time we will be growing to lots of nodes. I've told you how we're going to try to protect ourselves from malicious nodes. How are we going to attract nodes? Why would someone want to be a node? Well, I'll tell you what. You get paid to be a node, as you might imagine. Every ledger has to do that, and every ledger does that. So how would that look? Well, this is not a proof of work system where you have to have a supercomputer and use more electricity than the nation of Ireland to run the thing. This is a proof of stake system. And I think a lot of people have understood that proof of stake is a good way of doing things. So what does that mean? So proof of stake means that whoever's running the node has an account with H-bars in it. They have the cryptocurrency. And they say, I am staking this cryptocurrency as I am running this node. And we say, fine. Then once a day, we're going to pay you for being a node. Thank you for helping us out for this day if you were running all day. And we pay you proportional to how many coins you were staking. And the consensus algorithm weights all of these votes proportional to how much you were staking. So your stake is actually representing how much you're helping us come to consensus. The bigger your stake is, the more you helped us get to consensus. So this node payment is proportional to it. It's a reasonable thank you. The more you help us, the more you get. And there'll be limits on how much you can stake, so that if you have 1 trillion H-bars, which you won't, because the supply is fixed, it'll never change, it'll never go up to 1 trillion, it's just fixed at 50 gigabars. If you have a lot, then you're encouraged to stand up multiple nodes, because there's a limit to how much you can stake. By the way, did you notice I said stake? I did not say bond. I did not use the word slash. I did not tell you how we're going to steal all your money. There's a reason I didn't use those words. We do not do that. There is no bonding here. There is no locking up your coins. This node can spend its cryptocurrency at any moment, and it just gets paid less. You know, the less you're staking, the less you're being paid. But you have nothing locked up. And there is no slashing. We've actually designed everything to be so secure that we're not worried about people being malicious. There's just natural throttling and natural, worst case, if you do the worst possible things, and within a couple of seconds we just kick you off the network. There's no reason that we have to fine you. The only thing you could do is you could send out a fake transaction for which you'd have to pay a fraction of a cent network fee. That's the only thing you could do that would ever cost you anything. As a node, you're not gambling any money. There's no money at risk. You are simply just not going to get paid if you're not being a good player. If you're not keeping up and you're not contributing, then you just don't get paid. And so it's pretty simple. So this is the cryptoeconomics of why you might want to be a node. Now what about the mathematics of how proof of stake works? Remember, we're ABFT. And the theorems are you can't really do any better if you have a world with DDoS attacks and malicious firewalls. Spoiler alert, we have a world that has DDoS attacks and malicious firewalls. If you're in such a world, then no system could survive more than a third being evil, being malicious, being Byzantine. If every computer has an equal vote, then you can't have more than a third of the computers being malicious. If every H-bar, every token has an equal vote, then you have to make sure that 1/3 of the tokens aren't malicious, or just not participating. If 1/3 of the tokens are owned by malicious people, they can do bad things. If 1/3 of the tokens are owned by people who simply are not running a node and they're not participating, that's bad. It would stop us from coming to consensus. So what do? We want to encourage people to help the network run by proxy staking their node, their tokens, their H-bars. So a client, and I say client here, this isn't even a person who's using the network right now. They're just someone who happens to have H-bars in their account. The wallet software that you have says you have this many H-bars and will allow you to choose who you want to proxy stake to. So you can proxy stake to any of the nodes. And then what happens is that node in its voting is weighted according to its tokens and your tokens, all the staked tokens, the staked and the proxy staked. And that helps it then contribute to our consensus. And to the client, of course you're going to do this. It's easy to do. It's built into the wallet software, and it's easy to do, and then you are rewarded for helping us this way. Well, how are you helping? How are you earning something? By proxy staking. So we get a proxy payment to you. And why would the node even want you to proxy stake to it? We'll split it. So the node gets some of that too. So the node needs to try to be a good person and a non-malicious node with a good reputation so that people will want to proxy stake to it. And then we can split it. And so again, we're trying to get the economics to align with the incentives and align with human behavior and align with game theory to try to get it right. At least that's the attempt. I mean, that's the goal here. Nothing's perfect, and we're just trying to do the best we can. So this is what we're doing. So this then is why people are encouraged, and maybe it'll even be automatic in your wallet by default, your wallet software, to proxy stake your coins. Again, nothing is bonded, nothing is locked up. There isn't even any possibility of losing these tokens. And you can switch to the proxy staking to someone else at any moment you want to. And you can even imagine third parties having rating services for how reliable the node is. And if the node is offline every other day, then you wouldn't want to proxy stake to them. And we can have all these sorts of things. And then the incentives from the node payments, the proxy stake payments that happen once a day, if you are active for that day, for the whole day, then that is how we can incentivize everyone to be doing these things. So that's cool. That is how we handle payments. Now, I also talked about queries. Queries are interesting. You don't have to bother the whole network. In a very real sense, it is not Hedera that is helping you, it's one node. There is one node that you are having a conversation with, and you are asking it to do you a favor and give you some information. What's my account balance? What's in that file? Is that file even in existence? Could you please give me a cryptographic proof that I can show to a court that proves that file was in existence as of a certain date? Did I delete the file? Could you please give me cryptographic proof that I deleted it at a certain date? And I could show that to a court to show that my contract that required me to delete it was fulfilled. All these things are things that the node can give you. This is useful information. And so you could be asking the node of our mainnet. Our mainnet is the Hedera network that does the consensus. Everybody does the same thing. And in sharding, there'll be one shard of the mainnet that we're talking about. They all do the same thing. You can get your account balance, you get the file contents, you can get a record of the smart contract call results, and you can get these state proofs. And I think the state proofs are really a cool thing. Isn't it? You can also just as well talk to a mirror node. What's a mirror node? A mirror node is something that anyone on the planet right away will be able to do. I mean, we're doing this right now. We're doing the code right now. We want everyone to be able to do this. The mainnet will grow slowly as we're convinced that it's secure to grow it. But the mirror net can grow very fast. So the mirror net are going to be computers that keep a copy of the whole ledger. Every single bit of the ledger ends up in the mirror node. Every transaction that is flowing through the ledger flows through every mirror node. And the way it works is you don't even have to pay anything to be a mirror node, which is kind of cool. The mirror nodes help out each other by sharing information, and they don't slow us down. They don't affect our security. All the information flows from the mainnet to the mirror nodes, not backwards. The information is pushed, not pulled. The mirror nodes aren't even bothering the mainnet. The mainnet nodes are constantly picking mirror nodes at random and giving them some transactions, some events that they need. And it's the mainnet that's picking who to give it to. So there's very little possibility of a malicious mirror node corrupting our data or doing anything else. The mirror node doesn't have to digitally sign anything. It's very low stress. The mirror node does have to have enough bandwidth and storage and processing to do everything the mainnet nodes are doing, because it's doing everything the mainnet nodes do. But it gets all this information and we're not even charging for it. They just get it. And then they share it with each other. By gossip, same gossip protocol. And we use tit for tat to ensure that they do it, just like BitTorrent does and some other algorithms do. You make sure that, well, if you're not contributing to your neighbors, then your neighbors will stop contributing to you. And so it's just an information economy. There's no actual micropayments. There's no actual money being transferred. It's all very straightforward. This is the mirror net. And the idea is that lots of people might want to run mirror nodes. And you can ask, as a client, you can ask a mirror node any question that you would ask the main node. And it can answer you just as well, with state proofs to make sure it's not lying. And the state proofs have digital signatures from the mainnet, not from the mirror node. The mirror node doesn't sign anything. It's the mainnet that's signing these state proofs. So the mirror node's able to do everything that you could get from a mainnet node and more. If you want to, you could stand up a mirror node that keeps history. So you could not just ask it, what's the balance of my account? You could ask it, what's the balance of my account a year ago? And you could get a state proof that proves that the mainnet actually agreed with that a year ago. And you could do pub-sub systems. If you want to start a business that runs a mirror node, you can have pub-sub where somebody says, hey, anytime these accounts are touched or these smart contracts are run, please send me an email. And you can do micropayments to the mirror node for every email it sends you. And if you stop paying, they stop sending you emails. And if they stop sending emails, you stop paying. It's the beauty of micropayments for data. You could start a business doing that. Running a business, a mirror node doing a pub-sub kind of a thing where you have push information to the clients. The mainnet's not doing that. The mainnet's not doing history, but mirror nodes could do this. And the mirror nodes have the profitability. Or maybe not even that. Maybe a big company wants to run a mirror node just to give free access to all that information to all of its employees. Or maybe you're just a nice person. You want to do a mirror node and give the planet the information for free. Or maybe you are archive.org, who archives the entire internet, and you want to archive this. You can do it. Maybe you want to do data and analytics, looking at the hash graph historically and seeing what was the internet weather like, what was the behavior of the participants, all that stuff. As a mirror node, you can do all those things. And I am really excited to see what people decide to build in this whole ecosystem of mirror net nodes. And again, the incentive structures are, you might run it just because you want to know everything. That's it. That's enough incentive. Or you might want to build a whole business on it and have people pay you in micropayments with HBARs for your business. You could do all those things. So this is how the cryptoeconomics work. I just scratched the surface of it. Who knows if we got it right or not, but we're trying to get everything aligned, to have the incentives aligned, to have the game theory right, to have the economics right, so that you don't have a tragedy of the commons where things are overused. You know what tragedy of the commons is? If there's a free resource, it will be overused to extinction. And even the people who are hurt by the extinction will help contribute to the extinction. That's the paradox of the tragedy of the commons, which is why it's called a tragedy. You know, overfishing of the oceans is often a tragedy of the commons. It's terrible. Overgrazing of animals in a common area of land is where it gets its name from. So we're trying to avoid that. So what do? We have the fees that try to avoid that. We try to incentivize the nodes with our payments to the nodes. We allow the clients to do payments for data. You can do data micropayments, and you can even do it to mirror nodes, which can create an entire economy of mirror node businesses that are selling mirror nodes, or people doing it for free, or people just doing it for themselves or for their company, or to archive the internet, all these different things. We have lots of different pieces to this, but to the user, it's all very simple. Your software makes the transaction fee and does it for you automatically, and it's all simple. You're going to see stuff about a Chrome extension that I think is pretty exciting, that makes things really simple. I think you're going to see a demo of it. It's wait till you see that. But this is overall what we're doing. So I hope that was of some interest. Mostly it's all invisible, but I think it's interesting, and I think it's important. I really do think it's important to get this stuff right. Now, if you want to know more about our trust and how we build trust in the system and how we even trust that it's ABFT, I will be back later today and I will explain stuff about that. And it's kind of mind-boggling what we can do now, what computer science is able to do. And we'll talk about that. But for the cryptoeconomics, that's it. Thank you very much for your attention and thank you for being here. I very much appreciate it.